Hello everyone, welcome to the lecture series of the subject code KCS 403 with the subject name Microprocessor, and we know that this subject is related to the branch of CSC, Computer Science and its sister branch. And some of the students will study this subject in second year, and some EC students are going to study this subject in third year. So in this lecture, we are going to study the addressing modes of 8086. 8086 microprocessor. We know that it is a 16-bit microprocessor, and with the help of this 16-bit microprocessor, we can have the memory of 1 megabyte, which can be accessed. Now, the addressing modes are basically are addressing modes. Addressing modes are the one which defines the movement of your data. Means when we need to transfer data from one place to another place, or we can say from source to destination, how this data will be transferred, whether we are moving the immediate data to any register, right, or we are moving some data which is stored in register to another register, or we are trying to move some data which is placed at some memory location to another destination, right. So all these possible things will be covered in this addressing mode. So addressing modes as per the definitions are the one in which where the operand, that is your source or destinations, are stored. That is, it can be any memory location or any internal register, and it can also be some immediate data. And we know that in 8086 we have 16-bit registers. Those 16-bit registers, we can use them to store 8-bit data also, right. So those 16-bit registers are your AX register, right, BX, CX and DX registers, which are used to store 16-bit data, right. And these AX registers, they can be, we can view them as AH, AL, BH, BL, CH, CL and DH, DL, right. So these registers can be used to store 8-bit data individually, right. So if you need to store 16-bit data, we can name them as AX, and if we need to store lower byte, that will be stored in AL. If you need to store higher byte, it will be stored in AH, right. Some another 16-bit registers which we have covered in 8086, those are your source index, destination index, base pointer and your instruction pointer, right. We have these pointers also, which can also be used to store 16-bit data. And the segments which are present in 8086, they are named as code segment, data segment, then stack segment and your extra segment. Each segment will have some dedicated instruction pointer that will be used to calculate the complete physical address. For code segment, we are going to use instruction pointer as an offset address. These will be your offset pointers, right. For data segment, we are going to use BX and SI. For stack segment, we are going to use stack pointer and base pointer, and for extra segment, we are going to use DI, destination index, right. So these index registers, these offset registers will be used to calculate the physical address, and we have already seen that the formula for this physical address will be your segment address multiplied by 10H plus your offset address, right? So by calculating the actual physical address, we will calculate the address of any source number which we have to move from to another place. So by using this formula, we are going to calculate the physical address. So we have approximate 10 to 11 different addressing modes which we can use in 8086. The first one is your immediate addressing mode. Then we have absolute or direct addressing mode. Then we have register addressing mode. Then register indirect addressing mode. Then we have indexed addressing mode, register relative addressing mode. Then we have base indexed addressing mode, then relative base index addressing mode, data memory addressing mode, program memory addressing mode, and stack memory addressing mode. So the word immediate state that some immediate number will be given in the instruction, right? Then in case of this register word says that your source and destination will be in register, right? Then this indexed states that your source or destination will be having some index register, SI or DI, right? Then this relative word states that it will have some displacement. It can be 8-bit or 16-bit, right? So we must keep these a few things in mind while studying the addressing modes. Base index states that it will be using some index registers, right? So this way we are going to elaborate these addressing modes in the further slides. So first one, immediate addressing modes, as I have told you that some immediate number will be there in the instruction. So in this addressing mode, the operands are specified within the instruction, which means that the instruction will either contain the value itself or it will contain the operand which in which the values are required, right? For example, move AL, 28H. So this states that this 8-bit data will be saved in AL register. We have seen in the first slide that your AL register is capable to store 8-bit data. So this 8-bit data will be copied to this AL register. Then add AX, 2314H. It states that this immediate data will be added to the contents of AX, which will be the whatever the contents of AX is there. This content will be added to the contents present in AX, and your result will be updated in AX only. Then we have absolute or direct addressing mode. So in this addressing mode, your 16-bit memory address or offset address, we can say, is directly specified in the instruction as a part of it. For example, move AL, 1000H. So this bracket states that if you are writing some number in this bracket, it states that it is a offset address. And we are going to calculate the physical address. The data present, the byte present at that physical address will be copied to AL, right? So that address will be present in the operand, and this operand will be the part of your complete memory. So we have shown that this operand is the part of the memory, right? So so its physical address will be calculated, and then the byte present at that physical address will be moved to AL, because your AL is capable of storing 1 byte only. If you have written in this way, move AX, 1000H, right? So the data present at physical address, so a word will be copied to AX, right? So 1 byte will be taken from the lower address and the another byte will be taken from the higher address, right? So complete word will be, so in this a word will be copied to AX, and in this a byte will be copied to AL. Then we have register addressing mode. So in this type of addressing mode, the operand are stored within any of the internal register itself. So the processing of these operand is done either in those registers itself or by shifting their value to some another register, right? For example, AX, BX. Add AX, BX, whatever data present in BX, that will be added to AX and your result will be updated in AX. So it will be like this: AX, new AX will be AX plus BX, Okay, move BL comma AL, whatever the contents present in BL, this will be your destination. This will be your, this will be your source, and this will be your destination, right? We know that as in 8085. So whatever contents present in BL, that will be copied to AL. Subtract BL comma AL, the contents of AL will be subtracted from BL and your result will be updated in BL. Then we have register indirect addressing. So in this addressing mode, the offset address of the data is either in BX or SI or DI, base register, source index or destination index register. And the default segment we have seen in the first slide that the default segment, it can be either DS, data segment, or extra segment. The data is supposed to be available at the address pointed to the content of any of these registers in the default segment. For example, move AX comma BX, right? Move AX comma BX. We know that this BX, its segment is your data segment. So the address will be calculated in this way, that your data segment, the address of data segment, that will be multiplied by 10H plus the offset address of BX, right? This will be your physical address. This will be your physical address. So whatever data is present at this address will be copied to your AX. We know that suppose after calculating this these values, suppose the value of this DS is 2200 H and BX, I am taking just a random values example, that BX is your 2000 H. Right. So physical address will be 2200 multiplied by 10H plus, right, it will be 22000 plus 2000, it will be 24000H, right. So the data present at this address will be copied to AL and the data present at 24001H will be copied to AH, right. So 1 byte and then another byte, right. So because we are using AX, your word will be copied. Complete word will be copied from the source to the destination and the source address will be calculated in this way, right. Then we have index addressing mode. Here the offset address of the operand is stored in one of the index registers. As it is written here, it is index addressing mode. So it will be using index register, either your SI or DI. For SI, we know that we have the data segment as a default register, and your for DI, we are going to use this extra segment as a default register, right. Same way we are going to calculate the physical address, whether it depends on the destination register. If it is capable of storing 1 byte, 1 byte from the memory will be copied. If it is capable of storing 16 bits, it will be 2 bytes will be copied from the memory. Then we have register relative addressing mode. In this, data is available at an effective address formed by adding a 8-bit or 16-bit displacement. Because we have this term relative, I have told you that some displacement will be there now. Some displacement will be there. For example, we write move AL comma BX plus 08H. This will be known as your displacement. This will be known as displacement, right? So then base index addressing mode, the relative address of the data is found by adding the content of base register or base pointer to the content of index register. As the name implies, base indexed. So it will have base register as well as the index register, right? So the data present at this will be copied to either the destination or from your source will be this, or some destination will be this. Then we have relative base indexed addressing modes. Now we are going to have three things. First thing is your base register, then we have index register, and then we are going to have the displacement, right? So here we also going to have the index register also. Base register plus index register plus displacement, which will calculate the address of your operand. Then we have data memory addressing mode. So in this type of addressing mode, the offset address of the operand is mentioned in the instruction. So in the data memory addressing mode, first the offset address is calculated by the memory location, is calculated, and then the data stored at that memory location will be fetched. For example, move AL comma 2000H. So the data present at this address will be copied to AL. Then the data present at this BX register, whatever offset value is present in BX, we will calculate the physical address, and the data present at that will be copied to AL. In both the cases, your byte movement will be there. Then we have program memory addressing mode. So in these type of addressing modes, we are going to use the branch instruction. For example, where we need to use some jump or call instruction. For example, we write jump this address. So the instruction pointer will jump to this address whenever this instruction is executed. Then we have stack memory addressing mode. Stack memory addressing mode is dedicated whenever you have the stack instruction, whenever you are working on stack pointer, right? So as we have studied in 8085, your stack pointer is decremented by 1 because we have the 1 byte movement in 8085. But here we are working on 16-bit number, that is 2 bytes. So stack will be decremented by 2, and then your data will be copied, right? So the stack memory addressing mode is used whenever you perform some push or pop operation. We know that push operation is used whenever we need to store some data on the stack, and whenever we need to retrieve some data from the stack, we are going to use pop instruction, right? For example, we write this push BX, and the value of this BX is 1234H, and the stack pointer is initialized at 2000H. So suppose your stack pointer, here we have the stack, stack pointer, that is your 2000H. So SP minus 1, it will be your 1999H. Then SP minus 2, we are going to have 1998H. So BX is 1234H. Higher byte will be stored at higher address. So on this 1999, we are going to have 12H, and on the another address, on the lower address, we are going to save the lower byte, that is your 34H, right? So this way we are going to use the stack memory addressing mode. Then in 8085, your data memory addressing mode is further classified into these names, that is your direct addressing mode, then base addressing mode, base relative addressing mode, index addressing mode, index relative addressing mode, base plus index addressing mode, then base relative plus index addressing mode, right? So in case of direct addressing mode, the offset is specified within the instruction, which means that the offset address is directly stored with the square brackets and it is not present in any register, right? So whatever data present at this address, its physical address will be calculated and that byte will be stored to AL. Then move 1234H comma BX. Whatever data present in BX, that is your complete word, will be copied to this address, not to this address. So its physical address will be calculated, and then on the lower address, lower byte will be stored, and on the higher byte will be on the higher address, higher byte will be stored. Then we have base addressing mode. As the name stored base, it will either use BX or BP, base pointer, right, as a offset address. So so move AL comma BX, whatever data present in this BX register, it will be copied to AL, a byte will be copied to AL, right? Same way, please remember that we are going to calculate the physical address for each instruction, then your data movement will be possible, right? Then the base relative addressing mode. In this addressing mode, the offset address is stored within the base register, but there is a but the difference is that there will be some displacement present in this, and this displacement, it can be of 8-bit or 16-bit. Hence, the offset address will be equal to the content of the base register plus 8 or 16-bit displacement, right? For example, move BX plus 05H. Here your displacement is your 8-bit. Then move AL comma BX plus 1234H, 1243H, whatever it is. Here your displacement is your 16-bit, right? So this physical address will be calculated by adding this displacements, right? Your physical address will be calculated by adding this. So here your physical address will be, for BX we know that the default segment is your data segment multiplied by 10H, then plus your BX plus displacement, right? So it will be calculated in this way, your physical address. Then index addressing mode, as the name implies, index, your source or destination, it will contain the DI and SI. Some DI will be used or SI index register will be used, right? Move BL comma SI, whatever byte present at this address, we are going to calculate the physical address. Whatever byte present at that physical address, that will be copied to BL. The higher byte which is present in DH, that will be stored to that will be stored to the memory location whose result is saved in SI. Then index relative addressing mode. So some index register plus 8-bit or 16-bit displacement will be there. So in this addressing mode, the offset address is equal to the content of index register plus 8-bit or 16-bit displacement. And it is important to note here that the displacement in all the relative addressing mode is a signed number. That is, your displacement can either be positive or a negative hexadecimal number. Like for example, we have seen in this first example that move BL comma SI plus 07H. Here we have the positive displacement, positive 8-bit displacement, right? And here it is negative. Here we have the negative 16-bit displacement, right? Then base plus index addressing mode. So base plus index means some BX register will be used and we are going to use some index register, right? So base register plus index register, some SI or DI will be there, and here we are going to use some BX, right, base register. So in this base addressing mode, the offset address is calculated by both base register and the index register. Hence, the offset address will be equal to the content of base register plus the content of index register. For example, here your source is the sum of BX plus SI. Here your destination is the sum of BX plus SI. Whatever data is present by calculating this physical address, that byte will be moved to AL. So byte present at this address will be byte present in this CL register will be copied to this physical address. Then base relative plus index addressing mode. So here we have three terms. First we are going to have BX, then displacement, and then some index register, right? So three things will be there. So in this addressing mode, it is almost same to base plus index addressing mode, but some displacement will also be there, right? So for example, move CL comma BX plus SI plus 0 A. So here you have seen that this is your base register, index register and 8-bit displacement, right? Base plus index plus displacement. 8-bit displacement, right? Here we can see that, so in this byte movement will be there. Byte movement will be there because your destination is capable to store 1 byte only. So whatever byte present and this address, here we have, the only difference is 16-bit displacement. Right? So whatever byte present by calculating this address, that will be copied to AL, right? So same way we are going to calculate the physical address. We are going to calculate the physical address, that is your DS, data segment, multiplied by 10H plus this BX, whatever address is of BX, SI plus AE07H, right? So the data present at this physical address will be, byte present at this physical address will be copied to AL, right? So the byte present at this physical address will be copied to AL register. So this was all about the addressing mode, that is your data movement from one place to another place. So because in 8086 we have n number of registers and number of 16-bit register, so 16-bit movement as well as the 8-bit movement is also possible by using these registers. And secondly, we have studied when we are working on stack or some jump instruction or some branch instruction, we have some dedicated addressing modes that are specifically used for those purposes, right? So this is all about the addressing modes of 8086. Thank you so much.